Jupiter, a planet of hydrogen and helium, carries white-golden ammonia clouds scattered by the planet's rapid rotation. Winds of 600 kilometers per hour sweep through the giant's atmosphere, forming the Great Red Spot. It is a 3-century-old anticyclone, 3 times larger than Earth. The moon Europa glimmers because of its ice. Beneath its surface, Europa hides a deep, salty ocean, potentially with life. Saturn is mostly hydrogen and helium, with rings spanning 300,000 kilometers. Solar wind hits the atmosphere, creating intense ultraviolet auroras. Saturn's rings are made of ice and dust and are ancient, born in the age of the dinosaurs. Additional ghostly rings are revealed by the James Webb Telescope. Saturn's rings are incredibly thin, less than a kilometer, with an average thickness of 10 meters. The planet's shadow arches over the rings, casting a cosmic spectacle. In front of the rings, the moon Enceladus can be seen. Enceladus shoots jets of water and organic molecules from its underground ocean. Its surface is scarred due to internal tidal forces. In the background, the moon Titan blocks the sunlight, and Enceladus appears small in front of the thin rings. Jupiter is the largest planet in the solar system. On Jupiter, a polar ultraviolet aurora is powered by energetic particles captured by the magnetic field. Opposing winds fuel giant anticyclonic storms extending up to 300 kilometers deep. Heated gases from deep within rise to the surface of the gas planet. There, they are bombarded by the sun's ultraviolet radiation, generating all kinds of more complex molecules in a wide range of colors. Jupiter's atmosphere is 90% hydrogen and 10% helium, with clouds of ammonia crystals and hydrosulfide. At 50 kilometers altitude, they generate winds of 430 kilometers per hour. Here, 3 Jovian moons cast shadows on the planet's clouds. The shadow of the moon Europa crosses Jupiter's disk. The moon Io generates blue volcanic eruptions hundreds of kilometers high, fueled by tidal heat. Cracks on Europa, 3,000 kilometers long, reflect extreme gravitational stresses inside. The Cassini probe orbited Saturn for 13 years, capturing images of its moons and rings. Here, the Sun is eclipsed by Saturn, creating a spectacular halo of light around its rings. 5 Saturnian moons float above rings that are only 10 meters thick. The satellite Enceladus reveals an underground ocean and possible habitable hydrothermal locations. At Saturn's north pole, clouds create a stable hexagonal atmospheric current. The phenomenon is unique in the solar system and still unexplained. Here is a close-up image of Saturn's rings, made up of countless particles of ice and rock that orbit the planet. Saturn's atmosphere is mainly hydrogen and helium, with traces of methane, ammonia, and water vapor. Its moon, Titan, has an atmosphere made mostly of nitrogen with clouds of methane. Infrared images of Titan with false colors. Green represents the thick atmosphere, while reddish areas indicate sunlight reflections from liquid methane lakes. The Huygens probe landed on Titan in 2005, where rivers and seas of methane and ethane exist at minus 179 degrees Celsius. This is what it saw on the surface, the only photograph taken from the surface of a moon other than our own. This is what the surface of the dwarf planet Pluto looks like, photographed by the New Horizon probe. In 2015, New Horizon discovered 3-kilometer-high ice mountains on Pluto. Its satellite, Charon, has a rusty spot made of organic compounds. A global view of Mars from the northern summer solstice. Here is the satellite Phobos, above Mars, darker than the bright clouds, and a close-up image of Phobos taken by Mars Express. Mars's north pole is frozen. Although the planet's atmosphere is very thin, here you can see an elongated cloud called Arsia Mons. Olympus Mons is a giant volcano 3 times taller than Everest. Venus's atmosphere is mostly carbon dioxide. Due to the greenhouse effect, temperatures exceed 450 degrees Celsius at any time of the day. Venus is covered by a thick layer of opaque clouds, which contain sulfuric acid. That's why we can only map the planet's surface with radar. The planet Uranus has both rings and auroras captured by Voyager 2. In infrared, you can clearly see the methane composition of its atmosphere and its 13 rings. The white spots are solar X-rays reflected by the planet's atmosphere. Here is Miranda, Uranus's satellite has a diameter of 470 kilometers and wide canyons tens of kilometers across, the result of intense geological activity. Mercury is the closest planet to the Sun without a dense atmosphere, with daytime temperatures of 400 degrees Celsius and nighttime temperatures of minus 180 degrees. The surface of Mercury is covered with craters. The colors highlight the traces left by impacts with asteroids. The colored map of the North Pole shows vast volcanic plains formed by ancient eruptions. The yellow areas in the polar craters indicate the presence of ice protected by permanent shadow. At the end of their lives, stars explode like this red variable star known for its 2002 eruption and the striking light reflected in nearby clouds. Famous is the explosion in 1987 of a supernova in the Large Magellanic Cloud. The ring around the supernova is a structure of glowing gas formed before the explosion, later illuminated by the shock wave. Here you can see all three rings of glowing gas around the supernova formed before the explosion and now illuminated. A cosmic ghost? No, a star in formation, in motion. Strong winds from nearby stars create a tail from the gas around it. A cosmic sword? No. The two streams resembling lightsabers crossing the image are jets of energized gas ejected from the poles of a young star at the center. When such jets collide with the surrounding gas and dust, they can clear vast regions and create shock waves. This is a hypergiant, unstable star surrounded by a nebula created by violent stellar eruptions. Contrary to appearances, the unstable stellar system at the center has not exploded. What you see is only the matter ejected so far. Here, a massive blue star is surrounded by a ring of gas similar to that of a supernova which is getting ready to explode. When it does, as is happening here, the light will be so strong that we'll think a new star has appeared in the sky. The shock waves will light up the gas around the star, as seen in this measurement of a supernova that exploded in 1987. A new star emits a lot of ionized gas when it hits the dust and gas in the clouds surrounding the star. It generates light across a wide spectrum, from ultraviolet to infrared. The visible light is mostly absorbed, but the infrared light escapes more easily. The phenomenon is called Herbig-Haro, and the infrared photograph was taken by Hubble. The ring in the image is a protoplanetary disk around the star located 370 light-years away. I pointed with the arrow to where a planet named PDS-70c as big as Jupiter has already formed. And here are two giant exoplanets that were photographed for the first time around a star similar to the Sun. The Pleiades are a star cluster that can be seen with the naked eye. This is how I photographed it with my camera. When I look at such a star cluster, I wish I could go there. Here is a globular cluster located about 27,000 light-years away, containing hundreds of thousands of old stars, among the oldest in the Milky Way. I wish I could go there and experience sunbathing under several suns. In La Buchata, my village, you see thousands of stars, like tiny white dots. They are so far away that only the closest and largest ones can be magnified with modern telescopes. Here is one of them, Betelgeuse, with giant convective spots on its surface. Another one is Mira, a variable star that pulses regularly with a gas tail 13 light-years long. Here you can see Antares, a red supergiant with a turbulent atmosphere. Comets are icy bodies that form spectacular tails of gas and dust when they approach the Sun. Comets have two tails. The vapors from the comet are pushed by particles from the solar wind, forming a straight, bluish and faint tail. The heavier dust from the comet is also pushed by the solar rays, forming a brighter, white and slightly curved tail. Near the Sun, the comet can undergo small explosions, which change the shape of its gas and dust tail. The tip of a comet can contain molecules that emit green light when excited by the Sun's ultraviolet radiation. When it passes in front of a galaxy, the image is spectacular. Astronomers have obtained the most detailed image of a galaxy. The image contains over 500 nebulae. The disks of these two galaxies have merged into a ring full of colors, given by the various stars that are born there from interstellar dust. The blue and bright regions of this galaxy are full of young stars that are being born in the arms of the galaxy, where the density of gas and cosmic dust is higher. For us, The stars here are colonies of lost worlds, because we will never reach them in our lifetime. They are 16 million light years away. This galaxy triplet was named Tinkerbell after a character from Peter Pan. The red dots on the right are faint images of the most distant galaxies. The light from there has traveled for almost 13 billion years to reach us.